today. They ain't even put a workout this morning.
What? They just bailing on us? Alright, so numbers 1 and 2. What questions do you have? Before I just start saying things, what are your questions? So does that mean no questions? I can just skip it and move on? We knew how to do this?
No.
How do you know what to do first on one?
Okay, did you read the directions? CJ.
What does it mean to say the half plane?
Okay, talk about that in just a second. But what does it say right here? For each inequality and graph, do what?
Pick a point and use it to
Pick a point. Notice I picked a couple points. I did 5, 2, I did 3, -6. Literally, I just picked points. That's what it says, right? Give me another point other than 5, 2, or 3, -6.
0,
0, 0. That's a cool one. All right, so let's look right here.
So
If that point is a solution,
you would have to say, oh,
I would have to shade up. And how could I determine if that point is a solution?
you put it into the variable.
Well, so what is this point again? You said 0, 0. So what can take the place of y?
0.
The y value is 0, right? Is less than or equal to 1 divided by 5 times 0 minus 4. So 0 is less than or equal to, what's 1/5 times 0?
0.
What's 0 minus 4? So you'll tell me this. Is 0 less than or equal to -4?
No.
Which one is it?
0 is greater than
So remember, if you need to, go to a number line. Here's 0. To be less than means that it's to the left. Is 0 to the left of -4?
No.
So is this true?
No.
So am I supposed to shade up?
No.
Okay. So we do not shade up, which means we need to shade down. CJ, you asked what is the half plane? So this boundary line splits the graph into 2 halves. We're shading down. That's the half plane that they're talking about. Whenever you shade for the solutions, that's the half plane. That's it. Okay? Now I want to point this out. I only tested 1 point, but actually if you look again here, this is the point I chose originally. Now I will point this out. I specifically chose 5, 2. Because right here, I'm multiplying by 1. What does this fraction bar do again? Division divided by 5. Since I was dividing by 5, I picked what for x? 5. So I plugged in 2 for my y, 5 in for my x, and you can see the work here. 5 divided by 5 is 1, so still 2 is less than or equal to 1 minus 4. What is 1 minus 4?
3.
Negative.
-3. Is 2 less than or equal to -3?
Nope.
So here's -3, here's 2. Remember, to be to the less than is to the left. Is 2 less than -3? Is it to the left? No, it's not, right? So once again, something that was above the inequality, or above the boundary line, did it make the inequality true?
No.
So did I shade that half plane? No. Which tells me I do need to shade below, but you can even check. I used this point, 3, -6, and I wanted to show you can use things that give you ugly fractions. You can use a calculator. So I plugged 3 in for x, -6 in for y, and by the end I got -6 is less than or equal to -3.4. So -3.4 would be roughly here.
So,
Is -6 less than or equal to -3.4?
yes, sir.
Is it to the left?
Yes, sir.
So is it less than?
Yes, sir.
Thank you, Trey. I appreciate your engagement. Okay? So, did that point make the inequality true?
Yes, sir.
So which way was I supposed to shade?
Down.
That's it. But CJ, that's the half plane we're talking about. Right? And again, we had our boundary line given to us. I tested a point. I tested 4, 3. And when I plugged that in, was that true?
Yes.
Thank you. Was 4, 3 a solution?
Yep.
Yep, so I was supposed to shade
Upward.
up, because that's where it is. Alright? Now, I will remind you, we should be able to look at these inequalities and notice that if y is less than, which direction is that?
Down.
If it is y is greater than, it is.
Up.
Okay, we go with those ideas? Ready to rock and roll and move forward? Okay? Sorry, you writing some of that down? You good? Okay. So you'll notice I've already, I scratched out number 6 because that's a part of tonight's homework. But I would assume number 5 is the one that caused us the most trouble. Some of us rocked it. But I will point this out. Did any of us give this level of detail?
No, sir.
No, sir. What do you imagine this would score on the rubric?
If you didn't get it right, you could get a 5.
If you get it wrong, you could still technically get a 4 if it was a very valid approach. But my point is, if I got it right, what would this probably score on the rubric?
6.
That'd probably score a 6, right? Like, we want to recognize that. That's a 6. Do you need to get a 6 every single time?
No, sir.
No, but we do want to shoot for 5. Notice how there's justification here. So for the Trey and Amity, I think y'all both got this inequality, right?
Yes, sir.
Okay. What was the first thing you looked for when trying to write this inequality?
The y-intercept.
The y-intercept and the
Slope.
slope of what? Okay. Please hear me very clearly on this, RJ. Stop hitting your pencil. Pay attention. Same thing, Tony. Tony, what did you do to that pencil?
It broke right here with the ring.
Oh. Do you need a new one?
No, it's okay.
Okay. Please hear me very clearly on this. If you are going to graph an inequality, what's the first thing you need to graph? If you're going to graph an inequality, what is the first thing you need to graph? The what? The ultimate goal is to graph inequality, but what tells you which half plane to shade?
Boundary line.
The boundary line, right? You need that boundary line first to graph, don't you? And then you either shade above it or shade below it. So if we're going to write this inequality, what's the first thing we need? The boundary line. And Amity said that. She said, hey, look, I needed to find, or I saw the slope, or the y-intercept, and the slope of the boundary line. Because here's the thing you got to remember. If you're going to write the equation of a boundary line, there's only 3 different equations we've used so far. What are the 3 equations of a boundary line?
Slope-intercept.
Slope-intercept,
Point-slope.
point-slope, in standard form. And if I have a graph, there's only 2 of those I'm going to use.
Point-slope.
Point-slope and
Slope-intercept.
slope-intercept, right? And so you can use either one. It doesn't matter. To use point-slope, you just have to have a generic point and the slope. But if you have, if you want to use slope-intercept, you need what 2 things? For, you mean what? For slope-intercept? Remember, point slope would be a point and a slope, right? What do you need for a slope-intercept? Slope and? Which intercept? There's 2 intercepts that we can have. What are they? RJ, what are the 2 intercepts we can have on a graph? X-intercept and y-intercept. Remember, it's where we cross the x-axis and where we cross the y-axis. If we want slope-intercept, which one do I want? The y-intercept, right? And so, that's an easier equation. And Amity, what did you decide your y-intercept was?
-7.
This one?
Wait. 7.
7. I think that's kind of where your inequality went a little off, right? Notice, that's where the boundary line is crossing the y-axis, right? Now, it's not just a 7. I will say B is equal to 7, but what is the actual y-intercept?
0.
0.
0.
So the x value is 0, the y value is? Right? So then from there, I still need my slope. How do I find the slope from here?
I just looked at, like, when it was touching it, like,
Okay. Y'all are making this way too complicated. How do we calculate slope?
as of where,
Say, reword that a little bit.
Run.
Rise divided by run.
I see how,
Well, here's a point, right?
yeah, I see like with a, I want to say intersect, but like,
Where it goes through
through the
those.
line, through the line.
Yeah. So notice that you can choose any 2 points. I'm going down how far?
One.
Well, right
Oh,
here.
1, 2,
So positive or negative. And I'm going to the right how far?
3,
Is that positive or negative?
5.
Okay. Now we'll point this out. I could do something like this. Notice how far am I going down? Down 1. How far am I going to the right?
1.
Plus 1.
That's high.
And that's fine, right? So you did negative 1 divided by a positive 1. What's negative 3 divided by 3? Negative 1. What's negative 1 divided by 1? So does that give me the same slope? Right? You have to identify slope and y-intercept. So I would use y equals m negative 1 times x plus b 7. That's the equation of the boundary line. I'm like 95% of the way there. CJ, which direction are all the solutions for my inequality? Are they up, down, left, right? They're down. So Tony, if it's down, should I use a less than or equal to, greater than or equal to?
Less than.
Okay, so less than would make a lot of sense, wouldn't it? It's going down. So why did I also include equal to here?
Because it could be on the line.
How do you know in this case that it can be on the line? Look at the graph that's there. How do you know it could be on the line? What's the difference between numbers 5 and 6?
6 is, can you equal to?
How do you know, looking at 6, it cannot equal it?
Because
Just dash.
It's dashed, right? So how do we know it can equal here?
stop.
Stop.
There we go. We need to indicate that, right? Notice all this extra detail, right? Which I apparently forgot to finish here, but also the boundary line is shaded, or is solid, so we can equal it, but notice how it's shaded below the boundary line. I'm indicating y is less than or equal to. Notice I even checked it with a point, because 0, 0 is shaded, so it should be a solution, and it was. Right? This is a 6, right? These are all the details that we need to notice, but here's what I want you to recognize first and foremost. Just like with graphing, to write the inequality, what is the first thing you need to do? Start with what? Start with the equation of the boundary line. If you did not already know that, you need to write this here to use with tonight's homework. And to write the inequality, start with the equation of the boundary line. Because once you have that, it's just writing the correct inequality. To write the inequality, start with the equation of the boundary line. And this is why you have that graphic organizer to help you in writing the equation of boundary lines, to convert between equations of boundary lines. We all good with that? Okay, I'm going to leave the words up there. Can I erase this stuff though? We've already gotten this. Okay. So last detail, this should not be too bad. Do notice, and Amity, I want to point out something you said earlier. I think earlier on yours it said slope is something. What do you think? Slope is 3? Amity wrote this on her paper. Is the slope 3 for this line? Mm-hmm. Tony, where do you think that Amity got that the slope was 3? Trey, do you agree that the slope is 3?
No,
Why not?
3 divided by 1.
Well, what is 3 divided by 1? It's 3, so that'd be 3. Okay, so you do think the slope is 3. Okay. Why do you agree that the slope is 3?
Because rise over run.
But remember, this graph wasn't given to you. This equation was the only thing given to you.
Because the 3x,
It's 3x. So what's happening between the 3 and the x? They're being.
Multiply.
And what is multiplication?
repeated,
Addition.
So what are we adding by repeatedly?
3.
So would that be a slope of 3?
Yes.
Yes.
Also notice, isn't that the general equation, slope-intercept form? What does that 3 take in the place of?
And it's,
Just the end of the slope, right? Technically, what would my y-intercept be? If I'm not adding anything, I could be adding,
Three.
not 3. What number represents nothing, basically?
0.
What would my y-intercept be?
0.
0. Notice, and don't make this more complicated than it has to be. Notice right now, x is 5, right? Hey, what's 3 times 5?
15.
I messed up.
What's 3 times 1?
3.
What's 3 times 2?
6.
3 times 3?
9.
3 times 4? Remember, you can choose the inputs, and you just calculate the outputs by plugging them in. Don't make it more complicated than that. So, we gotta get going for today, but don't forget that's how we can go from the equation to tables and graphs. Let's look at our objectives, and we'll start with 5.5, all for one, one for all. Or keep going from yesterday. Yep. We probably will only get to this first objective, so we won't worry about the second one right now. Who read objectives yesterday? None of us?
I think I did.
RJ did?
No, I think you read it. You read them all.
Did Miss Ellis read all? I don't know.
I think
CJ, can you read the objective for us today? The very first one.
Okay, use a graph to identify the solution set for all inequalities in a system of inequalities represented algebraically.
Algebraically, right? So we're being given inequalities algebraically, and we're going to use what to identify all the solutions? Graph, right? So the idea of going from algebraic to graphical. So yesterday we looked at this idea that Carlos and Clarita have found a way to represent combinations of cats and dogs that satisfy each of their individual pet sitter constraints, but they realize they need to find combinations that satisfy all the constraints simultaneously or at the same time. Why do they have to find constraints that work for, or combinations that work for all of the constraints? We should have written this down yesterday. Okay, so it's doable or realistic. Okay, let's get a little bit more detail. What does that really mean here?
That the combination of cats and dogs don't cause an
Okay, is there a possibility that they would have enough money to do a certain number of cats and dogs, or set up for cats and dogs, but they don't have enough space for it?
Yes.
Is it a possibility they have enough space for a combination of cats and dogs, but not enough money?
Very possible.
So like, if they have enough space, but they don't have enough money, can they do that number of cats and dogs? No, right? So when we talk about these constraints, we have to satisfy all of them to make sure that we can actually make it happen. All right? So we already wrote this inequality, or this system of inequalities, right? Yesterday for number 1. What do you think this is over here?
System of inequality.
It's another system of inequalities. Why did I write this system of inequalities? Where did that come from?
Graph.
Graph of what?
The line equation for both of the constraints.
Okay, so not necessarily line equations, because it's not an equal to, is it? But what form do you have here?
Inequality.
Yes, it's an equality, but if it was a line, what form of the line am I looking at?
Everyone.
It is a boundary line, okay, but what form would you call this?
Slope-Intercepts.
Okay, but what is this one?
Standard.
So we had standard, and what did I write it as?
Slope-Intercepts.
Slope-intercept. We get with that idea? So notice both of these right here, that is my startup cost constraint. Alright, both of these here are my space constraint. How do you think I went from the standard form to the slope-intercept? How did I do that? I did use some properties of inequality. I would remind you that you have a graphic organizer to help you with these
This
things.
is what I was gonna grab, but
Because I converted from standard form to slope-intercept. Did I go from a complicated expression to a simpler expression? No, I don't have expressions, right? If you look at your graphic organizer, you just had it, CJ. Let's look at the idea of converting from standard form to slope-intercept. There's a very simple principle of what we're trying to do.
So you distribute it.
At the end, but look at what I started with. To get slope-intercept, solve for y. Did I get y completely on its own?
Yes.
Right, so I solved for y, that's all I did. But the thing I do want to ask here, and the reason I'm bringing all this up, is this. To correctly write this system, do I need to write all four of these inequalities? Should it really look like this? Should I write my system this way? CJ says yes, Amity says no. Raise your hand if you think we should write it this way.
no.
CJ? No one else? Okay, CJ, why do you think we need to write our system this way? What are your thoughts? Stop being scared to share. Be bold. Just share your ideas. What's up? Why do you think we should do this?
Did you think you another way?
So, because I can't do it any other way? Okay. Is there any particular reason you think I can't do it another way? Because, I mean, yesterday we wrote this system, right? We said that that was okay. But now I'm putting all four of these together to write this. So keep thinking on it. Let's hear what other people have to say. Trey, what are you thinking? You say no.
No, I didn't say no. I don't really know because I think, like since they basically the same thing, like you just change it. I think you can still write it like that because they all work together still.
Okay, they do all work together. Okay, Amity, you said no for sure. Why were you saying no?
Because they're equivalent.
Wait, yeah. What does this thing represent? This is the what?
The dog,
This is the startup cost, right?
yeah.
What does this represent?
Uh,
Startup cost? So they look different, but they're representing the same thing. So do I need both of them?
no.
So could I take this away and still have the startup cost?
They're equivalent.
They are equivalent. They look different, but they're effectively the same. I'd basically be repeating myself. Do I need to repeat myself?
No.
No, I've already got the startup cost. Does that make sense? Okay? So do I need both of these inequalities? No. They're both the space constraint. Boom. Now, once you notice, I took these two out. Do you think it's okay to have one in standard form, one in slope-intercept?
Yes.
They're both inequalities. Do we have the constraints that we need? So does it matter what form they're in? Okay, so I just want you to know we can mix and match. It can be multiple different things. Okay, so as a recap for yesterday, you all have 5 points for number 2, right? I think you all got pretty far along. Yes?
Yeah.
We all have 5 points for number 2. We all have 5. Do we all have 5 points for number 3?
Mm-hmm.
I only see 2 there.
Because I didn't finish copying.
You didn't finish copying them? You got 4 there. So let's do this really quickly. We got some points. What strategies did we use yesterday to find at least 5 combinations of cats and dogs that would satisfy both constraints? What were the strategies we used? What you got?
Substitute x,
Substitute just an x?
x and y.
Substitute x and y into the what?
The inequality.
To the inequality. If it's a solution to the system, it makes both of the inequalities
True.
true. Okay, cool. Was there another strategy we could use?
Look at the graph.
Look at the graph, right? How do we know when it's a solution to an inequality on the graph? Come on, how do you know when you have a solution to an inequality on the graph?
Boundary line. the shape,
Okay. The boundary line or what?
Like the way it's shaded.
The way it's shaded. So if it is a part of the shaded region, that point is a what?
Solution.
A solution, right? So if it was in both of the shaded regions, it was a solution to both. Now, what I just passed out was my own set of solutions to 5.2. It's just the graphs, but I indicated which graph is which. This is just to help you in case your graph is a little off or it's hard to read. But yeah, we need to plug points into both inequalities. We want them to make the inequalities true. We need to examine the shaded regions. So to make sure everyone's on the same page, what were the 5 combinations of cats and dogs that would satisfy one constraint but not the other? What were some of the points y'all had yesterday?
10,
19,
11,
19, 11, what else?
10, 5,
10, 5,
25, 5.
25, 5,
30, 4,
30 and 4,
0 and 20.
0. I don't think 0 and 20 works for 2, or for both, for one but not the other. Check 0 and 20 again. I'm going to check each of these. Look at the graph though. Could 0, 20 work for both inequalities? Or for either of the inequalities?
no,
How do you know?
it's not shaded. Well, like if you look at, if you was to put the point on the graph, the one you said,
If you put the point on the graph, yeah, notice what's the maximum number of dogs?
16.
16 in one and only 15 in the other. So could 0, 20 work?
Those
No, so we can't have that one. We need at least one more.
13.
13,
I think 13 and 1 works for both. Did you mean 1 and 13? Remember, we're trying to look for number 3 right now. Points that would satisfy one but not the other.
25 and 10.
25 and 10. Okay, I'm going to check these in a second. So let's go ahead and write these down. I might have to tell you to take some of these off, and we'll talk through that. I believe, doesn't 0, 16 work for one of them but not the other? I think it's too high for the space, but it was just
Yeah.
right for the startup cost, wasn't it? So we have a few here to get started. What I need you to do now, and this is what we're working on for the rest of the period, is number 4 here. Shade a region on the coordinate grid that would represent the solution set to the system of inequalities, right, that you found. Now, really quickly, what is the first thing you need to do in order to graph just one inequality? What's the first thing you need? The boundary line, right?
Yep.
Notice I'm asking you to graph this system, so how many boundary lines do you need on this one single graph?
2.
You need both boundary lines on that one graph. Does that make sense? So let's go ahead and get that down. Get your 2 boundary lines on one single graph. Notice you don't have to reinvent the wheel. Didn't I already give you, and you already have it from before, but didn't I already give you the graphs?
Yep.
So are the boundary lines going to change? So talk it through, make sure you understand how to get the boundary lines on there. If you need a piece of graph paper, let me know, or just come grab it, but you should have some from yesterday because I passed it out. So go ahead and work together. I'll be checking up on how those graphs are going.